proportional. So the corresponding sides of similar figures are proportional. As we talked about yesterday. That means we are going to set up a proportion using the scale factor to find the missing sides of similar figures. And a proportion is just a fraction equaling a fraction. Okay, so an example of a proportion might be like x over 5 equals, let's say x over 2 is equal to 3 over 6. That's a proportion. Fraction equals a fraction. So that's what we are setting up to solve. Okay. Because corresponding angles of similar figures are what? What do we know about the corresponding angles of similar figures? What do we know about their angles? Their sides are proportional, the angles are congruent, right? The corresponding angles are the same in similar figures. So the angles are congruent, so when we solve, what are we going to do? If the angles are the same, we're going to set them what? Equal. So we're going to set the angles equal to each other when solving. So finding a missing side, you set up a proportion. Finding a missing angle, you set them equal. Okay, this is for similar figures only. So let's take a look at some examples. Okay. We want to find the missing sides in both of these triangles, knowing that triangle DFE is similar to triangle ACB. Well, first thing I'm going to do is label what my missing sides. I'll say this guy is X, and that one is Y. Then I'm going to mark my angles based off this similarity statement. It's really, really important to mark your angles so you know which sides match up. Hard to tell if you don't mark them. Okay? So I'm going to go based off that similarity statement. My statement is DFE. So D is first, it's going to get 1 arc. F is second, so it's going to get 2. E is third, so it's going to get 3. I'm going to repeat that same process in that top triangle. A is first, so it gets 1. C is second, so it gets 2. B is third, so it gets 3. By marking your angles, it helps you set up your proportion correctly. Trying to avoid the answer to the next question I was going to ask you. Are we finding missing sides or missing angles? Sides. And we have similar figures. So that means we are going to set up a proportion. So I'm going to do fraction equals a fraction. I just have to fill in my top and bottom of my fraction. What variable do we want to find first? It doesn't really matter in this scenario. Let's find x first. We're going to find x. So I'm going to put x. That's what I'm finding. I just like to put it in the top of my first fraction. I look at my diagram. X is in between 1 and 3 arcs. Go to my other triangle. Which side is in between 1 and 3? 1 and 20. So x and 20 match up. So I'm going to say x over 20. We have to then set up this next fraction. Again, you have to stay consistent. The top triangle is in the top. So when we set up the second fraction, we have to follow that same pattern. Okay? Give me another side in that top triangle. 7. Okay. 7 is in between 1 and 2 arcs. What side in the other triangle is in between 1 and 2 arcs? 14. So we're going to say 7 over 14. Could we have used 8? We could have. What side matches up with 8? Yeah, if we have 2 different variables. You can have 2 of the same variable. That's fine. You just can't have 2 different ones. All right? So we could not have used 8, we had to use 7. So we have our proportion. How do we solve proportions? We did at the very beginning of the year. Cross multiply. You should have had some practice on that on the Canvas practice. So we cross multiply. X times 14 is 14x. 20 times 7 is what? 140. Divide, yeah, x by itself was 140 divided by 14. So x is equal to 10. Good the length of that side is. So now we need to find y. We're going to repeat that same process with y. Y is a missing side, so I need to set up my proportion. We want to find y, so I'm going to put it in the top of my fraction. Y is in between 3 and 2. Which side in the other triangle is in between 3 and 2? 8. This time around, when we made our fraction, we did the bottom over the top. We did big triangle over little triangle. Keep that same pattern. Give me another side in that big triangle. Doesn't matter. 20. Now that we know what it is, which side 20 is in between 1 and 3? Which side matches up with 20? 10, right? 10's in between 1 and 3. We didn't know that earlier, but now we know that that's 10, so we can use it. And again, we just cross multiply. 10 times y is just 10y. 8 times 10 is, or 8 times 20 is 160. Divide by 10. What's 160 divided by 10? 16. And then we're done. Found both of our missing sides. Questions over that? The big thing is you have to stay consistent. However you set up the first triangle, we did the first fraction, was small over big, so the second one has to be small over big. This one we did big over small, so your second fraction has to be big over small. You have to stay consistent. If you don't stay consistent, then you're getting the wrong answer. Questions over that? So we take a look at this next one. I'm given two similar triangles. We want to find the value of x. So these fractions, we call these triangles like bow tie triangles or hourglass triangles, because it kind of looks like a bow tie or an hourglass. Okay? We have triangle ABC. A to B to C. And we have triangle DCE. DCE. Okay, those are our two triangles. Let's mark their angles. Okay, ABC. A is first, so it gets 1. B is second, so it gets 2. C is third, so it gets 3. And we have DCE. D is first, so it gets 1. C is, wait. Oh. Did I not fix it? Change this to DEC. This should be DEC, sir. Oh. E is second, so it gets 2. C is third, so it gets 3. I thought that was fixed. You might just have to come back, so I don't know if you're going to have time to take the whole thing. Because I need to finish this problem before I can get you situated. Just want to come back. Just come at the beginning of class. That way.
So like the next day or something?
Yeah, tomorrow. Come right at the beginning because I start teaching you and I can't like stop. So we want to find x. Is x a missing side or a missing angle? The missing side. So you're going to set up a what? Proportion. Alright, I'm finding x. That's going to go on the top. X is in between 1 and 3. Which side of the other triangle is in between 1 and 3? 6. Go back to the bottom. We did big over little, so you have to stay consistent. Go back to the big triangle. Give me another side in that big triangle. 8. 8 is in between 2 and 3. Which side is also in between 2 and 3? In the little triangle. 5. How do we solve proportions? Multiply. X times 5 is just 5x. 6 times 8 is what? Divide by 8 divided by 5? Totally fine to get a decimal. That's going to happen a lot. You get decimals. Makes me feel like I'm wrong. Nope, you're not. Okay, you'll get a decimal. If you get a nice decimal like 9.6, so you don't really need to round it, you're probably right. If you are getting a really long decimal with lots of digits, and it's not telling you to round, then you're probably right. Okay, so if you're getting nice decimal, you're not. Okay, if you're unsure, double check your math, double check your setup. More than likely, you're okay. Sometimes you set up the problem wrong and you get a whole number. You're still wrong. So just don't base it off the type of number you were getting. Okay? But an indicator is if you get a decimal with lots of digits where you have to round, but it's not telling you to round, then go back and check your work. Okay? But small decimals, you'll get that a lot. So to take a look at example 3, we want to find x. So we know these triangles are similar. So I'm going to mark my angles. DEF. So 1, 2, already my board. 1. That didn't even help. Try it again. Sorry for those who end up watching this video. Get my board 2 times in a row. Okay. So 1, 2, 3. D, E, F. And then we have C, B, X. So repeat that same process. 1, 2, 3. Is X part of a missing side or a missing angle? Alright, so we're going to set up a what? Proportion. X is in an expression. So we're going to write this entire expression right here in the top. We're trying to find X, so the entire expression that contains X goes in the top. That expression, X is in between 1 and 2 arcs. Go to the other triangle. Which side is in between 1 and 2 arcs? E, which is 30. Stay consistent. We did purple over green, so we're going to do purple over green. What's the only other side we can use in the purple triangle? 77. It's in between 2 and 3. What's the other side in between 2 and 3? 21. That's why it is super important to label your angles. It's not about where they're at. Notice how 11x plus 11 and 21 are both on the bottom, but they don't match up. Okay? These triangles have been flipped around. So that's why you have to mark your angles. Your angles are going to tell you which sides match up. Okay? And then when we have an expression, remember, put parentheses around it. So when you cross multiply, you multiply correctly. Come on, smart boy. So we multiply here. We're multiplying 21 by this entire thing. We're multiplying 21 by the entire 11x plus 11. And then when we multiply here, what is 30 times 77? What do we get? 23. To solve, what do we have to do with that 21? What do we have to do? Distribute it. If we distribute it, 21 times 11 is what? 231. Have I ever told you the trick about 11 when you multiply? No. When you multiply a number by 11, you split the first and last, and then you add to get the middle. So 21 is 231. So 22 times 11 is 242. So 25 times 11 is 275. Oh, 275. It's a little trick. You can just ask people, tell me, give me a 2-digit number. I'll multiply it by 11. 45. 45? 495.
Bruh.
So low. 685. Now,
I don't think it works for 3 digits. I have to double check.
96.
96? 900. Oh. I don't know if it works that high. 9,156?
Wait, what is it? 96.
I thought 156.
It's 1,000.
1,000. So there you go. See, I don't think it works. It only works up to a certain amount, but yeah. I don't know if it works past. Like any 2-digit number when the product is like under 1,000. Up and up. So yeah, little trick. You can do. Quick mental math there. So, and then 21 times 11 is 231. So then we move that 231 over. What is 2,310 minus 231? 2,079. Divide by 231. What do we get? 9. All those weird big numbers in our answer just ends up being 9. There we go. X is 9. Questions over that? Okay. Got a couple more. If we take a look at this one in the diagram below, M and Q. M and Q. This yellow triangle right here, over yellow, is similar, I don't know why I did that, to M O P, this big purple triangle. I like to call these stacked triangles. It looks like they're kind of stacked on top of one another. And these are stacked triangles. They share some pieces. They share some parts of their sides. Okay? They are similar. So mark your angles. I have M and Q. Read that same process. M already has an arc, so I don't have to write it again. Okay? So M gets 1, O gets 2, and P gets 3. M already has an arc from the previous triangle, so you don't have to put another arc. It's already represented. It's already accounted for. So we're trying to find X, and X is part of a what? Side or angle? Side. We're going to set up a proportion. Little saying that I've heard, I did not make this up. I can't take credit for it, but I have heard it. When you're dealing with similar figures and you're trying to solve, there's a saying that says, when in doubt, proportion out. You don't really know what to do, set up a proportion solve. It's probably right. Right? Little hint. So we want to find X. X is just this piece. Is that a side of a triangle? No. That's not the entire side of a triangle, right? It's part of a side. It's sitting on this big side of the big triangle. Okay. So the length of that blue side of that triangle I just highlighted is X plus 10 more. So what you're going to put here is you're going to have to put X plus 10. You just can't put X, because X is part of the side. The entire side that X is on is X plus 10. Okay. That side is in between 3 arcs and 1 arc. Which side of that little yellow triangle is in between 3 and 1? 10, right? So go back. The top was the big purple triangle. Okay? So give me another side in that big purple triangle that I haven't used. You just name the side, you don't have to say the distance. Can we use OP?
No.
Why can't we use OP? Yeah, there's a Y there. We can't use OP because it's Y. So we have to then use OM, this other blue side I'm going to highlight. What's the length of OM? 12, right? Part of it's 4, the other part is 8, so the whole thing is 12. Okay. ON between 3 and 1 arc. Which side in the little triangles in between? Did I label this wrong again? That's only supposed to have 2. That's what I did. I gave this one an extra arc. Oops. Sorry. ON is in between 2 and 1. Which side's in between 2 and 1 in the little triangle? 8. Again, we have this binomial in the top. Put parentheses around it. And then cross multiply. When we cross multiply, we're multiplying 8 by the entire top of the fraction. It's equal to, what's 10 times 12? That's funny. So what do we have to do with the 8? Distribute. So we do that. 8 times x is x plus 80 when we distribute. Move the 80 over. To get 40. Divide by 8 and x ends up equaling 1. Now we need to find y. Okay? Again, y is part of the side. Set up your proportion. We're finding y, that's going to go on the top. Y is in between 2 and 3. Which side in the yellow triangle is in between 2 and 3? 7. Okay? Y was part of the big triangle, so give me the length of a side of the big triangle. 12. Going back to the same side. Good. 12 we said matched up with 8. We can honestly use the same ratio we used in the last one. Totally fine. Okay. And then cross multiply. We multiply here. 8 times y is 8y. 7 times 12 is what? 80 what? Divide by 8. What's 84 divided by 8? 10.5? 10.5. See, you got decimals. That's a nice decimal. So you probably assume you're correct. If you're getting weird decimals and it's not telling you to round, you're probably incorrect. You can also get whole numbers and be incorrect. So just double check your work. Questions over that? So here in 5, in the diagram below, figure ABCD is similar to EFGH. So mark those angles. A, B, C, D. And then mark the other one, E, F, G, H. If angle C is 70 degrees, alright, and G is 8x minus 18, we want to find x. Well, in this scenario, is x a side or an angle? An angle, right? And what does he say about angles with similar figures? They're congruent. They're the same. So how would we set up this problem to solve? And then solve. Move the 18 over. Divide by 8. And 88 divided by 8 is... Questions over that? Okay, we got one more. One more quick one. We take a look at the last one. It's a word problem, but I think these are almost easier than the non-word problem ones. Okay? Michelle wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the flagpole, then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5 feet above the ground, and she was 12 feet from the mirror. Using the triangles, find the height of the flagpole to the nearest 100th of a foot. Okay. Well, we have this big triangle here, this yellow triangle. And we have this little green triangle. Okay, these triangles are similar to each other, except in the directions. Okay? Well, we want to find the height of the flagpole, so I'm going to label that X. And that's representing a side in that yellow triangle. So what are we going to set up to solve? A proportion. We're finding X, so I'm going to put that in the top. Okay, go to the little green triangle. What length is representing X? Or matches up with X? Yeah, right? X is the flagpole. It's up and down. So I'm going to go to the little triangle. The person, Michelle, is representing a miniature flagpole. Okay? And her eyes from the ground are 5. So the two parts that are up and down are going to match up. What's the only number? Again, we have to go back to the big triangle. What's the only other number in the big triangle? 48, right? 48 is the ground from the pole to the mirror. So you're going to use that same part in the little green triangle. What's the distance from the person to the mirror? 12. And then how do we solve the proportion? Cross multiply. So x times 12 is 12x. What's 5 times 48? 40. Divide 12 on both sides. What's 240 divided by 12? So the flagpole is 20 feet. There's some human error in there, but it's not. And that's not as good. You could do that. You want to find something tall, but near, make similar triangles. Or called indirect. Questions over that? No? Okay. Here's your practice.